Hello class. So in today's lecture, we're going to talk about Harrod-Domar, the economic growth model. And this is the general outline of this video. Concept and growth theories, introduction, assumptions, derivation of fundamental equation, types of growth rate and steady state, phase equilibrium, implications and relevancy, and finally, the criticisms of Harrod-Domar. So before going to Harrod-Domar model, let's understand the concept of growth and different growth theories. So what is growth in economics? Growth means an increase in the amount of goods and services produced by an economy over time. Usually, it is measured by the rise in GDP. So there are different theories that have been developed for nation's economic growth. So some of the popular growth theories are classical theory, where growth depends on capital accumulation and the division of labor. Here capital means plant and machinery, or those goods which helps to produce other goods and services. And similarly, according to Keynes, under short run, growth depends on aggregate demand and can be managed by government interventions. And similarly, according to Harrod-Domar model, the model that we are going to talk in this video. So in short, it suggests that economic growth depends on saving rate and capital output ratio. And similarly, according to Soloswan, per capita growth depends on exogenous, means external technological progress. And similarly, according to endogenous growth theory, growth is self-sustaining and depends on innovation, human capital, and knowledge creations. So these are the different growth theories. But in this video, we are just going to talk about Harrod-Domar model. So let's go to the Harrod-Domar model. Introduction to Harrod-Domar model. So here SD model was developed by Sir Roy Harrod in 1939 and EVC Domar in 1946 independently. That is why it is called Harrod-Domar model or SD model. So it is one of the earliest theory to attempt to explain the economic growth of a nation. And this model was developed after the Great Depression to understand how economy can grow in a stable way. So economic growth rate is determined through the interaction between accelerator and multiplier. So here, what is accelerator? Here accelerator, it is the change in investment due to the change in income. Here accelerator means due to the change in income, which is cause, and with the change in income of the consumer, they increase the demand for goods and services. So with the increase in demand, the producer or the investors observing the increase in demand, they will reinvest or they will increase the investment. So here accelerator means nothing, but it helps to increase the investment. Here how the investment increases, because with the increase in income of consumer, they further demands more goods and services. So with the increase in demand, producers thinking that to increase the more profit or to increase their income, they will further reinvest. So that's what we call accelerator. So now let's come to the multiplier. So here I means investment and Y means output or income, and del I and del Y means change in income and change in investment. So here income is the cause and investment is the effect. So now let's come to the multiplier. So here multiplier is it's just the opposite of accelerator. So here multiplier means it is change in income level due to the change in investment. So here in change in investment is the cause and change in income is the effect. Here multiplier is nothing. Here what multiplier does is it increases the income. In accelerator increases the investment, helps to increase the investment, and multiplier helps to increase the income. So it's just the opposite of each other. So here when there is initial investment, it ultimately increases the income. That's what we call multiplier. So these two are the multiplier and accelerator effect. So pictorially we can say that, so initial increase in investment, through the multiplier effect it increases the income. So with the increase in income through the accelerator effect, it further increases the investment. So when this cycle continues and goes, it increases the economic growth. That's it. So SD model is the integration of classical and Keynesian theory. So how? Because it integrates both classical theory and Keynesian theory. So according to classical, they believe on supply side. Supply creates its own demand and ignores demand side. And investment is seen as a supply side factor, where with the increase in investment, firms hire labor and labor produces goods and services. So they get wage paid, and goods produced are bought with those wages. So here accelerator means, as I already told you, an increase in demand for goods encourages firms to accelerate investment in capital goods, the machine, factory, etc. So according to Keynes' view, they believe on demand side, and demand creates its own supply and ignores supply side. So investment is seen as a demand side factor, and investment increases aggregate demand. So now when there is increase in investment, firm hire labor, wages paid, workers spend income, and with the higher demand, firm produces more goods. So here multiplier, as I already told you, an initial increase in investment creates a multiple increase in income and output. So SD model, it integrates both classical and Keynes view. So SD suggests that investment have dual effect on demand side and supply side, because under classist, investment is seen as supply side factor. In Keynes view, investment is seen as demand side factor. So SD model, Harrod-Domar theory, integrates the both concept of classical and Keynesian theory. So after introduction, now let's come to the assumptions. Full employment level, using all labor and capital resources efficiently, no government intervention, closed economy. For simplicity, it does not consider foreign trade, import and exports. So factors are used in fixed proportion. That means if 2 capital and 1 labor, then for 4 capital we need 2 labor, which means the ratio of capital and labor are same. That's why it looks like in L shape, the production function looks like L shape. So MPS and APS are equal, where MPS is constant and MPS equals to change in saving by change in income. That means it is a part of extra income people save instead of spending. Similarly, saving income ratio is constant. Investment equals to saving. That means all the saving are automatically invested, and capital output ratio are constant. Here COR, it means how much capital is needed to produce 1 unit of output. That means to produce 1 good, how much capital we need. And generally developing country have higher capital output ratio, which reduces economic growth. Similarly, and developed economy have lower core capital output ratio, where COR, core C equals to del K upon del Y. That means change in capital by change in income. And marginal product of capital, MPK, is constant, and production function gives constant return to the scale. So MPK means additional output produced by using 1 more unit of capital. And similarly, there is no adjustment lag. That means there is no time lag. As investment increases, it increases production capacity instantly. So no change in technology, and constant population growth rate, and no capital depreciation. So these were the initial assumptions of SD model. So after assumptions, now let's come to the derivation of fundamental equations. So according to SD model, the fundamental equation comes from demand side effect and supply side effect. So let's go through demand side effect. It is also known as income generating force and works multiplied time level of investment. Here demand side is also known as Keynesian view. So here Y equals to 1 by S times investment. This is equation 1, where Y means output or income, and I means investment, and small s means MPS, and 1 by S means multiplier. So multiplier times investment comes in income. So multiplier helps to increase the income. So let's say if MPS saving rate is 0.1 and investment is 5 million, then multiplier formula is 1 by S, so which comes to 10 times. And now total output is multiplier times investment. So when the investment is 5 million, then 5 million times 10 equals to 50 million. So this is the simple example of multiplier and output. So now, as we know that SD model is dynamic model, so we have to convert each equation with respect to time. So after differentiating the first equation with respect to time, so we get dy upon dt equals to 1 by s upon di upon dt, where 1 by s is coefficient. For coefficient we didn't take derivative, so investment is di upon dt. So this is the equation 2. Now let's go through supply side effect. So from supply side, it is also termed as capacity generating force, which works accelerated times stock of capital. This is also known as classical view. So yp equals to sigma times capital stock. So here this is equation 3, where yp means potential output and sigma means accelerator, which is greater than 0, and k means stock of capital. So as we know that we have to differentiate with respect to time. So after differentiations we get dyp upon dt, and here accelerator is coefficients, so we don't do differentiate of this one, but for stock of capital k is dk upon dt. And here one thing you need to know is dk means change in capital stocks. So when there is change in capital stocks, that means there is investment. So instead of writing dk, now we can write I, because dk means I, investment, because change in stock of capital means due to the investment. That's why in place of dk we can write investment. So this is the equation 4. And now let's come to the equilibrium condition of an economy. Demand side equals to supply side, where demand side dy upon dt, I bring it from equation 2, and similarly dyp upon dt, it came from equation 4. So by equating demand side equals to supply side, we get equation 5. So again, after replacement of values from equation 2 and equation 4 to equation 5, then we get 1 di upon s dt equals to accelerator times investment. So again, by rearranging investment and saving rate, then we get 1 di upon I dt and equals to accelerator times saving rate, which is called equation 6. And this is the fundamental equations of SD model. So again, here dy upon y, this means economic growth rate. Change in income by income means economic growth rate. Similarly, 1 di upon I dt means change in investment, that means investment growth rate. And similarly here sigma means accelerator and s means saving rate. So ultimately the economic growth rate depends upon saving rate and accelerator. So this is very technical equations. When you are asked to derive the fundamental equations of Harrod-Domar model, then you have to go through these all 6 stages or 6 equations. But for simplicity we have alternative methods. The alternative method is economic growth rate z equals to saving rate by capital output ratio, where here the saving rate is same, but instead of accelerator we have capital output ratio. It's just nothing but the reciprocal of accelerator. So here capital output ratio c equals to del k upon del y, as I already told you about accelerator and multiplier in my intro part. So this is all about fundamental equations of Harrod-Domar model. So besides this fundamental equation growth rate or short-run growth rate, Harrod-Domar also defines other types of growth rate. So Harrod-Domar first defined simple short-run growth rate, and for long-run steady state growth rate, Harrod-Domar further classifies 3 types of growth rate: and actual growth rate, warranted or desired growth rate, and the last one is natural growth rate. So now we are going to talk in details about all these 3 growth rates. Okay, the actual growth rate, the growth rate an economy is actually experiencing or realizing, it is determined by the actual saving rate and the actual capital output ratio. It is the short run observed growth rate. It shows the total demand growth rate of an economy. So here GA means actual growth rate, which comes from del y upon y. So again, del y means del k upon c. So how it comes? So when we rearrange the accelerator, we get del y equals to del k upon c, and similarly how y equals to s by small s, because through saving functions we know that saving function equals to small s times y. So when we rearrange it, we get y equals to capital S upon small s. So again, when we reciprocal it, we get I upon c. So from where I comes from del k, because we know that change in capital stock means investment. So instead of del k, we can write I, and c is same, and when we reciprocal it, we get this one. And now we know that according to this modal assumption, I equals to s, that means saving equals to investment. That's why we can cancel this one. So the remaining part is small s by c, where c means capital output ratio. So this is this equation we already derived in our fundamental equations. So this is what the actual growth rate. And now let's come to the warranted or desired growth rate. It is the growth rate that makes business owners happy. It is the rate needed for the economy to grow in a way that fully uses all of its new capital. It is that type of growth rate where all the producers are happy because they are producing their goods as per their expectations or as per their desire, because in this state they are using all their resources, all their plant and machineries. That means their plant and machinery are fully utilized. So it shows the total supply side growth rate, and the formula is same here. GW equals to saving rate by capital output ratio, but this core ratio is not actual capital output ratio, but instead of actual capital output ratio, here we have capital output ratio is expected capital output ratio. And now let's come to the natural growth rate. The maximum possible growth rate, it is determined by the growth of labor force and the technological progress. So this is the long run potential of the economy. The natural growth rate is the ceiling or maximum for what's sustainable in the long run. So again, for natural growth rate, it is the sum of labor force growth rate plus technological progress. So Gn equals to labor growth rate plus technological progress. Let's say labor growth rate is 2% and the technological progress is 3% of an economy, then the total natural growth rate is 5%. So which is the maximum growth rate of an economy. Now let's understand three different growth rates from figures. So on x-axis we have time period, on y-axis we have growth rate. So Gn is natural growth rate, which is 7%, or it is also known as maximum growth rate that an economy can achieve by utilizing its existing all labor and technology. So now GW is 4% growth rate, which is warranted or desired growth rate. So at this growth rate, the producer or investors are fully utilizing their plants and machineries. So at this growth rate, they are earning their expected income and increasing their products. However, generally in developing country, the actual growth rate is lower than the warranted growth rate, so which causes deflationary period, because at this stage demand is lower than the supply, because the economy existing potential is 4%, but they are actually realizing 2%, and sometimes the actual growth rate may be greater than the desired growth rate, so which turns to the inflationary pressure. So now here let's come to the steady growth rate. Again, if all these three growth rates become equal to each other, it creates steady state growth rate, which is also known as golden age according to Robinson's. So when natural growth rate, warranted growth rate and actual growth rate equals to each other, it leads to the steady state growth rate. Steady state means long run growth rate. In long run, the economic growth rate increases every year, every time period by 7%. However, all the variables are changing, still the growth rate remains stable for long period of time, which is called steady state growth rate. So now let's study steady state growth rate equilibrium in details. So it is a long run equilibrium. Steady state growth means the economic growth rate remains constant over a period. For example, if GDP increases by 7% each year and the economy neither grows nor shrinks than 7%, which indicates that the economy remains stable over a period. So when economy experience actual growth rate, warranted growth rate and natural growth rate equal, then it is called steady state equilibrium or golden age. But the problem is at the steady state where all the growth rate are equal to each other is very rare case, which is also called knife edge problem, because at this steady state all the growth rate are determined from the different variables and all are independent to each other. So according to this model, one of the main problem is it is very difficult to attain the equilibrium, and once the equilibrium is attained, it is very difficult to maintain the equilibrium. So once the growth rate deviates, then it further go away farther from the equilibrium. Now let's understand the knife edge equilibrium. So for simplicity, we take just actual growth rate and warranted growth rate. Here we don't take natural growth rate because natural growth rate depends on labor force and technological progress. So under knife edge equilibrium, actual growth rate is equals to warranted growth rate. Here actual growth rate means S by C and warranted growth rate means S by CR, which means here S means saving rate, MPS, and C means actual capital output ratio, and similarly CR means expected or required capital output ratio. So after mathematical operation, here S and S cancel and we get 1 by C equals to 1 by CR, and after cross multiplication we get CR equals to C. That means when actual growth rate is equals to warranted growth rate, we expected capital output ratio also equals to actual capital output ratio. Here you need to remember this equation. So this is the point where producer desired output is equals to the actual demand from the economy. So at this stage where there is no excess production or shortage, desired capital output ratio is equals to actual capital output ratio. So but this point is highly unstable or knife edge problem. Even a minor deviation from the equilibrium leads to either recession or an inflationary pressure. So what happens if there is a minor deviations? Let's say when actual growth rate is greater than warranted growth rate, again the process is same, but instead of equals to, now we are putting greater than sign. But here when actual growth rate is greater than warranted growth rate, then we get expected capital output ratio greater than actual capital output ratio. So this means actual demand in the economy is greater than supply, so which causes inflation in the economy because actual income grows at a faster rate than that allotted by the growth in the production capacity of the economy. So again, what happens if warranted growth rate is greater than actual growth rate? So again the process is same, but instead of equals to sign, now we are using less than sign. So when warranted growth rate is greater than actual growth rate, at this situation we have actual growth rate greater than expected capital output ratio. So again in this situation actual demand in the economy is less than the supply, so which causes deflation in the economy because actual income grows more slowly than that what is required by the production capacity of the economy. So here required capital output ratio is smaller than actual capital output ratio. Now let's go to the implications and relevancy of this model. SD model suggests that a country's economic growth rate is determined by its saving rate and the capital output ratio. Policy implication in developing countries are poverty trap. This model suggests that developing countries are stuck in a vicious cycle of poverty. Here vicious cycle of poverty means chain of poverty, where poverty is the cause of poverty. So here low income leads to low saving, which means low investment, and thus low economic growth rate. This in turn keeps low income. This means low saving is the main cause of low economic growth rate. And the saving gap, the model highlights a saving gap where developing countries' domestic savings are insufficient to finance the investment needed for rapid growth. Similarly, need for foreign capital to overcome this saving gap, the HD model implies that developing countries must seek foreign aid or foreign direct investment. This infusion of capital from abroad can kickstart the growth progress or process. So, infrastructure investment. The model focus on capital accumulation, emphasize the need for a large-scale investment in physical infrastructures like road, power plants, and factories to boost productive capacity. Now let's go to the limitations or criticisms of this model. It assumes fixed capital output ratio, ignores diminishing returns to capital, assumes constant saving rate over time, overemphasizes investment as the only driver of growth, neglects role of labor force growth and productivity improvements, does not account for institutional and structural factors, ignores issues like inflation, trade, and government policy, assumes all savings are automatically invested, unrealistic assumptions of full employment, no mechanism to adjust when actual growth rate is not equals to warranted growth rate. So instability problem. So furthermore, especially in developing countries, extra income in low income countries is often spent on consumptions rather than saved, which makes difficult to increase the saving ratio. Similarly, in developing countries, household saving don't always translate into the greater funds for firms to invest because of weak or underdeveloped financial system. Similarly, efficiency gains are hard for developing countries because their weak human capital leads to inefficient use of capital, preventing a lower capital output ratio. Thank you. Any comments?